Hey guys, it's Mrs. Grella. Today's lesson we're going to learn about the exterior angle theorem. It involves exterior angles of a triangle. Exterior angles is what it sounds like. It just means angles that are outside the triangle. So notice that the highlighted angle here is outside of the triangle. And we have like a triangle, but we also have like an extension off of one of the vertices, vertex C. It goes to point D and it goes infinitely in the right direction. And so there's an angle that was created here because of that, and that's an exterior angle. Angles A and B are interior angles, and there is a relationship between these two interior angles that are not adjacent to the exterior angle. We're going to find that out in a few minutes. What I want to do first is try to see if you can figure out, based on what we learned the other day, what that highlighted angle, angle BCD, would be. So let's take a look at this triangle here. I know angle A and I know angle B. So if I wanted to, I can find this pink angle, angle C. Well, technically it's angle BCA because there's BCD, which is the outside one, and BCA, which is the pink inside one, and those are different. So I can technically find that angle if I look at this as just a triangle by itself, right? I know that these three angles of this triangle inside of it have to add to 180. So using what we learned in the previous lesson, if I take my 55 and my 45 and add them up, that's 100 degrees so far between the two of these. So the third angle must be 80 because if the total is 180, if I take away the 100 that I know that I added up, I'll be left with 80 degrees remaining. So this must be 80 degrees, angle BCA. And that makes sense because again, if I cover this and I look at the three angles of a triangle, if I do 55 plus 45 plus 80, it adds to 180. And all triangles add to 180 degrees, the angles inside, they sum up to 180. So what does that have to do with this exterior angle here? Well, if I notice, this exterior angle is supplementary with the interior angle BCA, which is 80 degrees. I'm going to highlight with my blue highlighter, noticing how this question mark angle and this 80-degree angle make a straight line. Straight lines are 180 degrees. So if I take my total straight line of 180 and take away my pink angle, 80 that I found, if I cover that up, if I take that away, I'll be left with the question mark angle, which is actually 100 degrees. So my question mark must be 100 degrees. That's interesting because when I added these two angles up, I got 100 degrees. And that was the answer to the exterior angle. That's actually the exterior angle theorem. It states that the two remote interior angles, meaning the two angles that are not next to the exterior angle, their sum, when you add them up, equals that exterior angle. So angle A plus angle B is equal to angle BCD. And we showed that because angle A was 55 in this case. Angle B was 45 degrees, and then together it equals 100, which makes sense. And that's what our angle was. This works for all triangles that look like this. All right, so you can see that in the applet I posted on Google Classroom as well. You could see in this example. I can give you another example. Very similar example, but I'm going to give you now. This is 20 degrees, and this is 35 degrees. Actually, let's make it 85 degrees. Okay, so I have 20 degrees and 85 degrees. If I want to figure out this angle, angle BCD, that exterior angle, I don't have to do what I did in the previous problem. I did that to kind of show you where it comes from. But knowing now that this interior angle plus this interior angle is going to equal this exterior angle, I know that now. So I can just do 20 plus 85, and that'll give me my answer. So 20 plus 85 would be 115. no, 105. So this is 105 degrees. All right, so there's a quicker way to do the exterior angle theorem. You can do it the other way too. You can find the other interior angle and then go back and find the exterior angle using supplementary angles like I did here, but this is a quicker way. Also, it's good to know problems that involve where you know the exterior angle. So let's say I know the exterior angle this time. I'm gonna do the same diagram, ABC, with an extension on D. Let's say I know this angle is 120. So I know the exterior angle, but maybe I don't know one of the interior angles. So maybe I don't know angle A, but I know angle B is, maybe angle B is 40 degrees, right? Well, again, I can figure out what this angle is using supplementary angles and then figure out what this is using the sum of 180 theorem. But I also know that angle A plus angle B equals the exterior angle BCD. All right, I know that. I know that this angle, inside angle plus inside angle equals the outside angle here. Well, if I don't know angle A, so like what plus 40, which is angle B, would equal 120, which is angle BCD. You could just subtract 80, right? 80 plus 40 would give you the 120. If you do 120 minus 40, that would give you 80. Or you can think of it as a variable, x plus 40, because you don't know it, equals 180. And to solve that equation, wouldn't you subtract 40 on both sides? So you get 80 that way. All right, either way, this is 80 degrees because these remote interior angles are supposed to add to the exterior angle. All right, so that's your exterior angle theorem for you using numerical problems. What I want to do is take a look at one more problem that involves algebraic problems. Let's take a look at that on the back. Let's say I have the same triangle A, B, C with an extension at point D. And I want to figure out what X is. Well, let's take a look for a minute. So pulling up a problem, I want the numbers to work out nice. All right, so let's say that this measure is 10x minus 7. And let's say this angle is 3x plus 13. And let's say this angle is 2x plus 10 degrees. So again, with the variables, there's really no way of like subtracting from 180 or, you know, adding these up to figure out what that is because you don't know what this is, you don't know what this is, and you don't know what this is. All variables here. So you have to use the theorem. The theorem states that the two remote interior angles, angle A plus angle B, is equal to the exterior angle BCD. So what I can do is set up an equation. I can take this and add them together. This would be A. This would be B. And set it equal to the exterior angle, which is the 10x minus 7. I can set up an equation based on the theorem we learned. All right, so again, inside plus inside equals outside. That's how you would do it. They don't add to 180 because this is not an interior angle. This is an exterior angle here, not inside. If this was inside, then that would be interior. They'd add to 180, done. This is different. Inside plus inside equals outside. So now I have to solve this using my DCVS. I can't distribute, but I can combine my like terms. Now this time I have variables on both sides because I have a 10x here and a 5x here. I didn't have that in the last lesson, so I kind of just solved it pretty easily. Here I have to remove the smaller variable using inverse operations. So I'm going to do a minus 5x to both sides. So that leaves me with 23 equals 5x minus 7, because 10x minus 5x is 5x. I'm then going to solve for x by adding 7 to both sides. If I add 7 to 23, I get 30. So 30 equals 5x. Dividing by 5 to isolate x, I'm left with x equals 6. All right, so again, that's my x value. That's not my angle, that's my x value. But that does help me because then what I can do is I can substitute x into each one of these angles. All right, so if you look at up the above diagram, angle A is 3x plus 13. So 3 times x plus 13. 3 times 6, right? 6 is x. So 3 times 6 plus 13, that would be 18 plus 13. That would be 31. So I know that angle A is 31 degrees. All right, I can do the same thing for angle B and also the exterior angle BCD. So for angle B, I go 2x, so 2 times 6 plus 10. All right, I'm replacing the x with 6 because that's what it equals. So 2 times 6 is 12. 12 plus 10 is 22 degrees. So I know that angle B is 22 degrees. So I wrote that in. All right, so I have 31 and 22. I bet you this one is going to be 53 just because I know that this one plus this one equals this one. But I'll double check because I know when I add those up, I get 53. I'll double check by plugging it in though. Angle BCD is equal to 10x minus 7. So 10 times, x was 6, right? Minus 7. So 10 times 6 is 60. 60 minus 7, 53. I knew it. This is not drawn to scale, obviously. This looks like a very obtuse angle, yet 53 degrees is acute. It's less than 90, but it's not always going to be drawn to scale. So our math is correct. It's just the diagram's not really drawn to scale. But that's how you would solve the exterior angles theorem. So whenever you have an exterior angle and you have variables, remember to set the two interior angles, add those up, the sum of the two interior angles, and set them equal to the exterior. So we did angle A plus angle B, and we set it equal to angle BCD, and we solved it.